Okie dokie. So I gave myself a nice little note start here. Look at the C# JSON stuff. So we've been talking about different ways of representing data over the last couple of classes. Not necessarily saying one way's always better than another, but certainly as you start getting into more and more uh, I don't know, complex data like you saw last night working with the YouTube API. It was giving you the information in JSON that you had to extract the pieces. It probably gave you like a video ID, 20 other things. But, so you saw it in practice that JSON is that communication language that you use going both directions. And kind of the middleman, which you probably wouldn't see very often anymore today, would be that XML stuff. Um, you know, Not difficult to wrap your mind around, but kind of an important stepping stone in history type thing. One interesting thing you can, if you want to sort of explore the internet with it, is most of our modern browsers have a setting where you can turn on XHTML. So I think I mentioned last time that HTML, being a tag-based language, came before XML. So XML said, hey, we like this idea of a tag-based language. Can't we have tags that are used for things other than like making web pages? So XML became a tool for inventing your own tags and that kind of stuff. And since it's an opening and closing tag, you can easily parse it. Well, many websites are built using some automation tools. It's less of a problem today. I would say the tools give you much, much, much better quality HTML today. But if you have any websites that are based on some older tools, the original problem was a Microsoft product from years ago called Front Page. And Front Page would generate, you would create your web page like it was a Word document, and then you'd save it, and it would save as an HTML document with pretty janky HTML. It didn't always have a closing tag and stuff like that. So then what ended up happening is all the web browsers had to make all these exceptions to make less than perfectly formed HTML pages still show up decently. And that's why if you end up becoming a web developer, one thing you'll end up doing is you will have to test your user interfaces, the actual web page itself, on multiple browsers to make sure it looks correct on the 2 or 3 or 4 different browsers. Um, it's probably less of a problem today. I think most of the browsers today will interpret HTML the same, but because they have so many backwards compatibility things with old sites, they do have some differences on how they process them. But most of our browsers today, all the mainstream ones, somewhere in their settings have a thing where you can enable XHTML mode, which says only work for a properly formed HTML, where there's always a closing tag and things like that. And then go and browse the web for 20 minutes, you realize how many sites break. It tells you a little bit about the tools they might be using for building the initial framework for their sites and things like that. So similar to the Y2K bug, a problem that we created. I mean, what was that? Probably in the late 90s, something like that, 98, 99. So 25-year-old problem still haunts us today. All right, so we want to look at today how, and this is really a C# thing, not necessarily a Unity thing, how C# can be written to manage JSON code. So we want to introduce a couple of terms here. I'll go ahead and bring up the code so you can see it. So there's our sample JSON, and here's my item CS. So, I've created a class called item, and we had looked at this before. I think I told you to ignore this serializable thingamajiggy. All right. So, a couple of words to understand is serializing in programming is the act of taking an object, probably when it was first associated with programming. It wasn't necessarily just for objects, because you could do this for structs and things like that as well. But I think in practice today, it would always be an object. It's the act of taking an object and converting it into an easily transmittable, is that a word? So with yes, an easily transmittable format for sending, usually to APIs. Maybe historically would have been for sending information between two computers. So you would take your objects, you would have to serialize them into some sort of format, and does it for the programming language, they can have it be a proprietary format if they want, because you're probably using their own deserializing tools as well. So which is called marshalling. So serializing, turn it into something that can be transmitted. The antithesis of that is called marshalling, taking serialized data and turning it back into objects. All right, so kind of an automated process. Now, when we look at this code, and we say that, this is the form, this is the syntax in C# for it. But when you look at this word right here, serializable, does that bring back any memories of anything in Java? What did we talk about in Java that had a bool at the end of it? It was when we dealt with threads. What was the a bool we dealt with threads? Go ahead. Runnable. And what kind of animal is that? Runnable was something in Java, what was that? What was that class, and what is it, or what was that animal, and what does it tell us to do? So I'll throw it out there. So it's an interface in Java. What do interfaces do? What's the purpose of an interface? This kind of aligns with what a comment I just made a second ago. So it kind of gives a set of rules for a certain function or set of functions must exist. So if you're going to implement an interface itself is not an implementation, just like design patterns are not implementations. Design patterns are a kind of a rule of thumb. A interface would be a rule of thumb that is being enforced, something like that, where we say specifically for runnable, which is a pretty simple interface, it says you have to have a function called void run. If you're going to implement the runnable interface, you have to have a function called run, or else we're going to scream at you. All right. So serializable also is an interface in C#. If we went and looked at this, actually give us our so here's our public interface, serializable, and it has it actually looks like this is an older version of it, but it gives us an idea of it, because I think this was called serializable, but this is good enough for this example. This says you have to have a function called get object data that takes a couple of parameters from it, and its job is to get the object data from an object. So turn it into the proprietary string that's going to be sent by this. So you can either use the built-in implementation of this that C# already has built in, or you can write your own proprietary piece if you want to implement serializable for your own stuff and just say, okay, well, this is what the string looks like. In our case here, we're using the built-in version of this. So we do that in Java, we would have said implement serializable. We're in C#. The syntax is a little bit different, just like the syntax for inheritance is a little different, and writing the constructors to call the parent constructor, that kind of stuff. All right, so we have this class called item that we flagged as being serializable. We've said an item is going to hold 3 pieces of information. This is just a plain Jane object like anything else. So name, stat impacted, modifier. Constructor looks like just any other constructor. And then we have this serializable thing for another class called root object. So these things kind of work together to serialize the data. So we're using C#'s definition of this. And the root object here is going to be a collection of items. We talked last time that you can have one of the benefits of JSON over XML is it allows us to have arrays. We can have collections of things. So in this case, our intention is to be able to have a instance of an object that holds a collection of items that were marshaled from a serialized stream. That we don't have to worry about all that implementation stuff because C# has that stuff built into it. So unless we're doing something very proprietary where we want to deviate from C#'s normal way of doing it, we would just use their serializable implementation for working with this stuff. Java works the same way and has a very similar approach to this. One rule of thumb when you're working with certain languages, and this is one of them. So when I taught about object-oriented programming, we always said make our classes have our attributes or fields be private, and then only loosen the reins as needed. So right off the bat, we look at this and say, okay, well, this doesn't look like it's great programming practice. This would be an example of what we had to do to be compatible with the serializable interface. We had to make these guys public. And why is that? Anybody have a theory as to why the item class had to have public fields when it comes to serializing and marshaling? The emphasis being on the marshaling process. Any theories? So imagine when your program is reading in data that has been serialized and we need to marshal it. And marshaling it means basically turning the serialized stream back into actual objects. What's likely happening behind the scenes? We're probably creating an empty instance of an item and then directly setting the public fields rather than passing it to a constructor. Okay, so what it's doing is it's creating a generic item with probably, default values. So empty string, 0 or something like that for the 3 parameters for the constructor. And then what it's doing is it's specifically saying I.name equals this piece of information. I.stat impact equals this information. And the only way we can do that, the only way you can externally access those fields is if they're public. Make some sense? So that's kind of an example there of if we're gonna play by the rules of the serialization mechanism that C# has, we got to make those guys public. Java's the same way. In fact, I don't know if I've seen a language that works with serialization similar to this that doesn't require it to be public. They're kind of always like that. So if you ever try to do this and you've started off with making things private like you're used to, and you find it not working, check there first. Rule of thumb. All right, so that's kind of the big difference we see here. So now let's go and look at where we use this. I have to remind you, it's within the shop controller, I think. Yeah. All right, so here in the shop controller, I do a couple of different things here. We'd already looked at reading in just the plain text file. So let's look at the JSON file with serialization. Okay, so the first thing I do is I read in this JSON string from read items data JSON. So this this function that I wrote down here. So this guy ultimately gives us a string. All right. So what does it do? We have our file path. that goes to our items data JSON.txt. So this is our file that we put some JSON in it. It's interesting. The only reason it has txt at the end of it here is because when you import it into Unity, it automatically, if it's a text file, automatically throws the .txt at the end of it when it brings it into the assets folder. Usually JSON documents would be something .json, but that's just kind of a naming convention. When you have the extension on something like a .doc file or a .docx, you look at that and say that's a Word file, right? A .pdf, that's a PDF Acrobat file. Anybody know what that's called when you look at an extension of a file and can determine the application that would be the default application to open it? So when you double click on a PDF on your computer, it's opening whatever your computer's default PDF reader is, right? If you double click on a docx, it opens up Microsoft Word. Do you know what that is called? That translation there? Pretty old term. It's called a MIME type. MIME type. So there is a kind of a lookup list in most of our modern operating systems that has that translation between file extension and the MIME type for which application you should open. And every now and then, you've probably seen on your computer, you'll get a file that has a weird extension on it. A good example would be like a RAR file, where usually there's not a built-in application for de-archiving RAR files on your computer. You have to go and download some free application. It'll pop up and ask you, what program do you want to open this with? And there's usually a little checkbox that says always open with this file or something like that. So that would add a MIME type to that lookup table. That's kind of what's happening behind the scenes in your operating system. All right, so long explanation to, we have text on the end of that thing because that's what Unity does for us when we drag it in. All right, so then we have our same checking as the file there, blah, blah, blah. This is just normal file IO stuff. So this is where we're looking at the serialized JSON parsing. So we're going to use this stream reader, just like we did in reading just normal text. We're going to read in a line of that text. So we're basically just reading in our whole JSON string. All right. And ultimately, we return the contents of that file. It's just a plain Jane JSON string. All right. It's already in a format. So now when we come back up here, what got returned there? Well, we set it equal to this thing called a root object. Now, if you remember here, let me go back over to item. A root object is a collection of items. All right. Notice that this guy is public. All right. And notice that it implements serializable. So because it implements serializable, there is a hidden function in there that will take that JSON string, and because this one of the default serialized formats for C# is it understands JSON. There's also a version for XML that can still be used because you do still have a bunch of old data that is stored in XML because you've already done it. If it's not broke, why fix it? Type thing. But we're going to create an instance of root object, and we're going to let the magic of C# take our JSON string and turn it into a collection of items, an array of items. What's an item? Well, it's these three pieces of information that we've now taught it how to extract. Another thing to point out, besides these things needing to be public, the values here, let me show you in our, is this the JSON one? Name, stat underscore impacted modifier. Name, stat underscore impacted modifier. Those names need to match the attributes in your JSON file, because it's going to rely on that to go and read those pieces of information from our string. All right. Shop controller. All right. So ultimately, we're using this JSON utility. Okay, with this string, this JSON utility, it's built in here. We're going to give it some JSON. So we're giving it that JSON string, which is just a plain text string. We're telling it, convert that guy into this thing called a root object, which we already defined. We're telling it that the nature of a root object is going to be a collection of items. All right. And the JSON utility will use its from JSON using this serialized definition of a root object to ultimately give us an instance of root object. So this is where the magic is happening. Make sense? That's where ultimately C# is turning your text version of JSON into an object, which is a collection of item objects that has our stuff in it. All right. Now, I don't know if I've shown you this before in C#, but there exists a for each loop in C#. So we've traditionally used for loops and while loops. And I want to say I probably showed you a for each loop in Java at some point where it would have been for item root dot items. That would have been a header in Java. Those two lines, line 28 and 29, mean the same thing. 28's the Java version of that. 29's the C# version of that. All right, so this requires that thing on the right-hand side to be a collection type. In this case, root is the name of our root object. And we saw that root object has a public variable called items that is a collection type, an array. You will probably notice if you've previously worked with Python, Python also uses the in keyword for doing similar things. All right, so we're going to go through this collection of items, and for each of those items, we're going to store it. Each pass through this loop is going to store that instance of item inside of this variable called item. That way we don't have to say items at bucket I. You just get the item. If you happen to need that value I for something, you probably want to write it as a traditional for loop in case you need not just the value there, but also the count, the position. So a for each loop isn't always the best tool for it, but in this case, we just want to get our items. So we're going to print something out to the screen. This is a formatted, I think I mentioned this before. This is a formatted string, similar to what we saw in with printf, or I think we looked at printf at some point with C++. But in any case, we're building a string and we just have little placeholders for the values that we want to display there. All right, so now we have access to those things. All right, questions about how to work with JSON in C#, and basically you now know how to do it in Java with just a couple of little flip-flops here and there. All right, make some sense? Out of curiosity, what language did you guys use last night?
Python, pretty much all the
time. Okay, and actually Python makes parsing JSON super easy. Because it comes in by default as a dictionary. So then you just use it. So you didn't have to, if you were working with a JSON string in Python, you require significantly less setup, something like that. Okay. So now that we're able to read these things in from our file, and we can put as many items in here as we want, we go back to our idea of a shop. So our shop looks like this. Now, right now, we have this guy defaulted to just having one thing here. What if we wanted to have our shop here read in our list of items, whether it's one item or whether it's 20 items, let's say, and generate the scene, the correct version of the scene to show us those items. Maybe you have it connected to the left and right arrow, something like that, where you know if you have 20 things inside of your items JSON, it basically shows you you can decide how many to show at once. Maybe you're going to show 4 things at once or something, and then you could press the right arrow and it'll slide those things over to show you the next collection of 4, something like that. We might want to look at how we can accomplish that. All right, so from the perspective of our scene here, this is still running. That's why my computer's been running so hot. From the perspective of a scene here, how might you set this up to show 4 items at once using what you know so far about Unity? A maximum of 4 items at once. Any ideas? Go ahead.
Could just put like a list.
Okay, well, what would a list look like based on what we've done with Unity so far? Okay, so all right, so you could do that. You could just have the text show up, right? What if we wanted to have some kind of item icon, whether it's the you know, a certain file name for your graphic, something like that, because we'd probably then have to include that in the JSON, right? You know, it's called, you know, cherry.png or potion.png if you had different pictures for your different stuff. But we could just have a placeholder thing for an item. Right now we have a cherry graphic for an item. So I mean, that's correct. You could use a Text Mesh Pro and basically just take your text here, turn it into a big string, or just put carriage returns in it and just say, here's your item choices, and you know, kind of could pick from that way. Now, if we ultimately want to have 4 items shown at once, let's call it horizontally, and then if I press the right arrow, those 4 items are replaced with the next 4 items. Whether you want it to slide in or just have them, you know, kind of roll over to the next thing. How might you accomplish that if we're gonna limit this to 4 items maxed to be seen at once? We kind of did this similar to how we handled our pellets, right? So maybe we can put some placeholders in here. All right, so let's just go in here. So right now we have this cherry variant thing. Now, one thing we might decide we want to do with this, though, is we might actually want to create a prefab specifically for like a selection thing. So if we think about our game, might there be other opportunities for us to show 4 elements at once with a right arrow and a left arrow that allows you to go back and forth between those collections? Right now, we want to use it for our shops, but we can probably in a couple of minutes use our imagination and come up with several other things where we might want to do something similar. Okay, and you remember back, we have these things called prefabs where we can write something once and then have that thing be used multiple times. So if we want to kind of go and invent that to build our prefab, what we'll do is we're going to start off, just so we can test this, is I'm going to go into scenes here. And I'm going to, I guess I got to do that through file, new scene. So we'll use our basic built-in scene, say create. And then we're going to go ahead and save this scene inside our assets, inside of our scenes folder. And let's call this guy prefab playground or something like that. This is probably not going to be a scene that we ever have our game ultimately go to, but it's something that we're going to use as like our sandbox for building some prefabs and being able to test them, disconnected from the idea of our idea of our shop. All right, so so we'll create this guy. All right, so now in this scene, we decided we want to be able to show 4 things at once. So let's go ahead and let's create an empty game object here, maybe called the collection. All right, and then inside the collection, we want to create, we can decide, are these 4 more empty game objects that we're then going to bring images into? Is it going to be a set um, game object? Maybe it's an image with a text mesh pro below it that gives the title, something like that. We can decide what makes the most sense. Let's see what our options are here. So if we want to add something to this, let me go back here for a second. I want to just take a look at what this cherry is stored as. So we probably bring it in as if we're going to have that image for our cherry being our placeholder for our items, which maybe isn't the greatest idea, but maybe we'll do it anyways. Or well, actually here, let's see. Image of item placeholder. Just see what that gives us here under images. Anything look interesting? Nah, let's just call that good enough. Better than a cherry for for a placeholder. So I'm going to save that image. And we're going to call this guy item placeholder. Put it in my downloads folder for right now. I'm going to go into assets. Do I already have an images folder somewhere? I don't. So I'll just create a folder here called images. I'll go in there and then I'll drag that placeholder in there. All right, so now let me go back to our scene. This is our prefab playground. We have our collection here. I'm going to go to my images. Let's just get this image. Oh, do I have to attach it to something? I do. All right. Probably a UI image. All right, so we'll create a UI image. It has a source image. If I click on this guy, will it let me choose my dude that's already in there? Do I have to drag him in? Oh, I need to store him in a sprite format. So let's leave him blank for right now. We'll look at, actually, I don't want to use a canvas. We're just going to make it look dumb for right now. I'll delete that. We'll go back and just bring in our, get rid of that event system that was part of that. I'm going to create some empty game objects in here. We're going to call this item 1, item 2, item 3, item 4. All right, so we have 4 items. Now, we might want to, we could probably also in here put in create a 3D object, let's create something called a plane. So a plane is flat, completely flat. Effectively, what I'm doing is I'm kind of creating like a little background scene to put something else onto. So we'll call this guy background. We'll put that under the collection thing here. We're probably going to put the items underneath that. So let's stretch this thing out a little bit. Where's my... Go with that. Might end up being too big in our other scenes, but we can always scale it. All right, so now underneath background, let's go ahead and let's create a 3D object. We'll create another plane. Let's call this guy item 1. So I'm actually going to get rid of these 4. We'll recreate these guys just for looks. So I'm going to make my item 1, item 2. We're going to make these guys planes that have a material associated with them. Let's go ahead and go into our materials. We'll go ahead and create a new material just for the sake of it. Here's our material. We'll call this guy item for no good reason. We'll in here, we're gonna pick our background for this guy, and I don't know, I picked a good enough. I don't know why I made it that color. Yeah, we'll say that's good enough. So that's our item. We'll go ahead and take this guy here. We want to let me move this item up real quick so I can easily grab it. Okay. And I'm going to go ahead and drag our item thing onto that. All right, then I'm going to shrink down our item to be roughly a quarter of the size of our can always resize our thing shortly. All that awesome. We'll copy this guy 4 times. And you can decide how perfect you want to get your layout to look. All right, then we'll go ahead and resize our background a bit. Oh, it's because those guys are children of that. That's fine. But just for a moment, I'm going to move those 4 items so they're not children of background. That way I can shrink down the background without modifying the children. Now, call that good. All right, then I can go ahead and take these 4 things and drop them back under the background. Go ahead and rename these guys. Item 2. Item 3. Item 4. All right, and these guys are just under our thing called the collection. So we have several options of where we might put the script for controlling this dude. Now, just as a reminder here, ultimately what we're going to be doing is we already have a prefabs folder. We don't, so I'll create a new folder here called prefab. Call it whatever you want. And what I'm going to do is I'm going to take this thing called collection. I'll drag it down there into that folder. So now we have our prefab for our collection, even though right now it doesn't do anything. But just as a kind of a reminder, now I can go back into my scenes, go to my shopkeeper, and I'm going to go ahead and just zoom in on the cherry thing. I'll go back to my prefab, drag this guy out here. So I've brought that into my shop. We can certainly resize the collection here. So under scale, we can shrink this guy down in multiple directions. Maybe decide the width that we want for this thing. So we have a scale of 0.2. So I'll go ahead and say 0.2, 0.2. And now we have the thing sized for our scene. Okay. So that's how we would bring in that prefab once it's good to go, if you will. All right. But right now it's not ready to cook, but this is just that connection we're going to make. So we want to go back into, I'll go ahead and get it out of here. We can always update it in here as well. We can go back, make some changes to it, then come in and have this prefab get updated automatically. But that's just kind of our cadence we're going to be doing. So we're going to go back into our scenes, into our prefab playground. I'll resave my scene here. Okay, so now what we want to do is we want to build this guy to show 4 things at a time, up to 4 things at a time. If we have less than 4 things, it should show us less than 4 things. And we want to then read from the JSON. So we already have some examples of this, and we want to bring them into this code. So chances are, let's go into our scripts here. And we'll go into our mono behaviors. And I'm going to go ahead and create a folder in here called prefab scripts. You can decide if this makes sense for you or not. Inside of prefab scripts, I'm going to create a C# script called the collection manager. All right. And we're going to go ahead and drag that script over to our collection. So I added it to that top level game object there. You can go in and start editing this guy, and we're going to have him do some pretty similar stuff to what we had here in our shop controller. So this is where we're going to read in our JSON string. So I'm going to steal these couple of lines and put it into start over here. All right, then we're going to go ahead and get our read items from JSON. You know, we could decide that, hey, you know what? I might want to read JSON items in multiple places in my application. So if that's the case, where might we put this function? Where would be a smart place to put a function that we're going to use in multiple places across our program? Go ahead, put it in our singleton. All right, so I'll go back to our shop controller. We'll go down to our read items, data from JSON. I copy that. I'm going to go into my singleton. Now you might decide that you're going to have, you know, our singleton's still fairly small. So you could have multiple singletons that do some different things. We'll go ahead and put it in here. So I'll put it in there for now. I'm going to have to make it public so I can access it from the other thing. And because we want to be more generic, what I'm going to say is I'm going to call this guy read JSON string, because we might not want to just use this for items. And right now it doesn't do anything special to for items. So we'll call this guy read JSON string. And we'll come into our collection controller thing here. And this guy will actually be our my singleton dot read JSON string. To where's my singleton? All right, now we need to have some other things in here so we can work with files. We can go and grab these from our shop controller and things like that. So we're going to have system IO and system, and bring those into our singleton. Okay, so that'll give us access to these things. I don't need these print statements in here, so I can go ahead and dump those. If you really want to have them in there, you can have the console dot, or that was a debug dot print or something along those lines. All right. I brought that in there. Go back to our collection. It still is not happy. My singleton dot. Oh, I need to make it static. Sorry. So there's our read JSON string. So now we have the ability to read that JSON string from anywhere. All right. So for your homework, taking this as a starting point, what I want you to do is have a look like this, or something similar to this. It looks like I actually have done some weird stuff in there, it seems like. But effectively read in from a JSON file your collection of items, show up to 4 at a time, and then allow them to hit the right and the left arrow to load the next or the previous grouping of 4 items into these things. And you can make it look however you want. Make some sense? Okay, so I'll update this code so you'll have my starting point. Note that there's a couple things that currently don't compile, and I'll put that assignment up. Shouldn't be too bad. I think you'll be able to use a lot of the pieces that we've had in previous things. Sound good? Questions, comments, concerns, bribes? All right, I'll see everybody on Friday.
Hey, Professor.
Oh.
How did you like drinking the Waleed under the table?
Wally doesn't drink, so that's nothing.
Or what was it? Eric? Eric was his name?
Eric is the owner of Aurora. Yeah. Now he held his
He
own.
should have